Now, like I mentioned, I will probably do some kind of a follow-up video where I do a little bit more of a deep dive into what was happening on the board and how I was trying to trace that signal. For anybody that is curious and they want to start getting into there, what I found online is that most of the videos that have to do with that kind of thing tend to make a lot of assumptions on what you know and what you don't know. And I'm going to make one that's, again, trying to dim it down a little bit, making computing more accessible, making it so that people are a little bit more adventurous and it doesn't seem like it's such a heavy lift. Although I'm sure that there's some people out there that listen to these videos and they don't understand anything I'm saying. I am trying to make this more accessible and to get more people involved.
As a word of caution, anytime you're working with electronics, please be careful. You can get shocked. You don't want to get shocked. You could lose your life or you could hurt somebody that you love. So if you're ever messing with electronics, find a professional to do it for you or exercise caution.
This might be a bit awkward, but we're going to try to figure this out. So what I have here is a multimeter. It's from Klein Tools. I have the dial set to voltage, and I had to use the selector button, that orange selector button there. There's the first setting when you originally turn it on to voltage. It's going to be trying to measure alternating current. For a component like this, we want direct current. Okay, so the first thing I did with it, you might remember the way that I had it configured to play games and to do the speech synthesizer. There's a lot more to the computer. What I did is I removed the speech synthesizer and the 32K sidecar and the Tippy. I removed the cartridge, the Final cartridge that was on here. I removed the keyboard, and we've just kind of stripped it down. I even unplugged the video because we know that the video and the audio coming out of here is fine. So the point of this debugging session would be to determine whether or not video and audio signal was getting to this plug. If video and audio signal is getting to this plug, if we see voltage coming through there, then we know that if it's not showing up on the monitor, then it's either the connectors on the cable, it's the cable itself, or I guess the connections into the monitors, or it's the monitor. So, the point is that it's not the computer board. If we have a signal getting to this plug and it's getting out of this plug, then we know that the problem is somewhere else. So my reasoning going into this is if I know that here on this component here, this is where the video and audio plug in. So it comes out of here and it goes into the monitor. The monitor is what's generating the sound in the video. So if we get a signal coming out of here, we know that the problem is either in the cable, the connectors on the cable, or the monitor itself. So the point of this debugging session was to try to determine whether or not this component was getting a video and an audio signal. So I need to know, of the 5 pins that are on here, remember this is a 5-pin DIN connection. We need to know which pins are audio, which pins are video, and there are charts all over the internet for that. I found one, and we determined which pin was the audio pin. So if we find out, okay, there's going to be signal getting to that, we need to look on the rest of the board here and try to find out, well, where does the audio pin generate? And so in one of the earlier sessions, what I found out was that this chip right here is the audio chip, or it does most of the audio function. And so I found a replacement chip from someplace in Hong Kong. They sent me a couple of replacements because I thought maybe this chip was bad, and that's why I wasn't getting any sound. So I replaced that chip in a previous video, plugged it in, tried to start it up, and it didn't work. So it wasn't the chip. And I have since replaced, like this is one of the new chips that I'd sent, but I took the old chip, put it in here, and it works fine. That chip is not wrong. So I now have 2 of these chips extra. If anybody out there needs them, let me know. I'll be sure to get those to you. But I thought the chip might have been bad. And there are, for the pins on the chip here, there's a specific pin that is the audio out pin. And so we can test voltage across that. We can test voltage across this. And if we care to, we can even flip over the board and you can trace where the circuit is going from component to component and see if you can find where there might be a break, because you never know. There's soldering connections onto various components, and there might be a crack in the board. There's all kinds of things that might cause that signal to just disrupt. And it might be solution. The fix might be as simple as taking a soldering iron, hitting that solder there, and remelting it. It might make the connection again, and you could be fine. But you don't know until you start poking around. So you get your multimeter, you set it to V, and what you're trying to do is you're trying to measure direct current. We're going to try to find direct current on this board. It's clearly a DC component there. So you have to set your multimeter to read direct current. Typically, I think when you turn on multimeters, when you get to the voltage setting, it's usually going to be AC. So you're going to have to figure out how to make it DC. On this particular one, you use that selector button there. Hit that button one time and you are in DC. I've already done that. I am now on DC. So if I put my positive and negative together, you can see it kind of jumping around there. Okay, so how do I test to see whether or not there is power on these pins, and how do I know which pins they are? So let's go find that. Let's go find that pin out diagram and figure out which pin is which. So you go to Google, you put in TI-994A 5 pin out, and you'll see a diagram that explains on the board here which of these holes is audio, which is video, and which is composite. Find out that this one here on the left is actually your audio. This is your 12 volt on the right. This one right here is your composite. That's your video signal. And the one on the bottom is the ground. The fourth one is nothing. I think it's nothing. But that's what, so we're going to look at this particular pin. So how would we connect, how would we test that? How would we know whether or not there's any signal coming from there? Well, if you look on the back of it, you can see, I'm going to do this without messing with the power supply. But on the back of this, there are these, whoops, no, you can't see this. No, you can. There are these ridges. So that small one there, that is the one on the left. That's the audio signal. That one right there is the one that's not used. I'm sorry. That one right there is the one that's not used. The one on the bottom that's straight in, that's ground. That's your your composite. And this is your 12 volt. So you can test voltages to those components, and you can also test the voltage from the actual hole here. And how would you do that? Well, once you get your multimeter set to DC, measure DC current, get that set up there. It's going to be a little bit fuzzy. You're going to put the ground anywhere on the edge of this entire metal ring that's around the board is actually a ground. So you can put it anywhere there, and you should be able to put your positive in there, and you should see a voltage across that. Right now this is showing, that's interesting that it's showing 0.8 microvolts or millivolts. That must be millivolts. Okay. Well, yeah, that doesn't mean anything. Yeah, 0.8 millivolts is nothing. Why aren't we showing any signal? Well, the computer's not on. So let's turn the computer on. For those of you who are new to this, never try to measure resistance across a component while the board or the component is powered up. You could ruin your multimeter. And of course, yes, I know that because I wound up trying to do that, and I did. I didn't ruin the multimeter. This one actually is a nice multimeter. I was able to reset it, but yeah, you want to be careful about that. Okay, so let's try that again. So if I put it on the ground there, it's jumping around, but you see it's reading microvolts or millivolts, whatever the hell. Can't get that right. Millivolts. So it's reading an incredibly small charge. That shouldn't be necessarily anything alarming. Let's see what happens when we put that in there. It's possible I can't get to it. It might not be thin enough. That looks to be the case. It's not thin enough. So let's try the back. Let's try to measure it across the back. How are we going to do this and still show? Let's turn this sideways. A little bit of a glare. Yeah, now we're cooking with gas. Okay. Let's switch these. I gotta keep my way over. Okay, so if I put this here, and if I touch that to there, I see. Where is it? Where'd it go? There it is. 61.6461, about 61 microvolts. Millivolts. 61 millivolts. So that's interesting. This is supposed to be 12 volt out. So if I put the probe there, you see it's 11.97. That's pretty much right on spec. So very nice. So that's accurate. The composite video, see what that reads. That's about 0.69 volts, 0.7 volts. The ground should be pretty much 0, and that is 4. There is nothing. And this one is supposed to be the audio signal, which is 51.4, 51.5 millivolts. Now, we need to be cognizant of the fact that right now there probably is no signal, that there might not be any audio signal, or it might not be strong. And so that might be why we're getting such a low reading. So one of the things we might want to try would be to plug in the keyboard and some of the other components here so that we can, verify that we have a signal going there, start up a game and see if that's actually, see if that changes from that relatively low reading. Let's give that a shot. Okay, now we're cooking with gas. We've got the keyboard plugged back in. I put the final ground cartridge in as well, and I plugged in the video and audio feed to the monitor. I'm going to start up TI invaders, let it go to attract mode, and then we know for a fact we're going to have a signal at that point. So let's see what happens here. If I turn it on, okay, pressing the key to begin. Well, that's interesting. Review module library. There it is. I think we've got a problem with the way I have my cassette plugged in here. Hold on. Yeah, that was it. Okay, I'm gonna go games. C. Invaders. Yeah, now we're moving. See how it's jumping around. 11, 26, 26. So that's interesting. Now there's nothing, so there's no sound. Huh. Very interesting. That's our video. The video's at almost 200 millivolts. 12 volt is still at 12 volts. Back to audio. Jumping all over the place. Okay, so what that tells us is that, the audio is getting to this jack fine. And so it must have been further along. Now, when I was doing this, like I said, I'm not a electrical engineer by any measure. So I had made the mistake of turning on the multimeter, and I was trying to use the AC settings to measure DC current, and so I was getting no readings, and I couldn't figure out what was going on. I was kind of thrashing around, trying different things. Nothing was working, and it wasn't until I got to the DC setting on the multimeter, read the instruction manual right, that I was able to figure out, okay, this is how you measure DC current, and this is, and things started making more sense. They started being, my poking around started generating some consistency. But the other thing I tried was I tried looking at that pin, that chip, they call it IC. It's an integrated circuit, right? It's a chip. And so I started looking at that chip. There's there's bunches of diagrams online that show which of the legs on the integrated circuit actually is the audio out leg. And you can again measure from that to the ground. You can measure and see if there is a voltage going across there. You can flip the board over and start trying to find, well, okay, where is this thing breaking? So if we look at the other side of this board, for instance, so let's flip the board over. I'll take this off. Take this off. Okay. I'm going to take the cartridge out. That unplugs nice and simple. And for that matter, let's take this off. Okay, if we flip this over, keeping in mind where things are, we're interested in that last pin over there. And if you flip this over, that would be, you can't really see it too well, but it'd be that one right there. This is your audio out pin. It's connected to the component. Apparently it's connected to the component right next to it. So if you flip it back over, that would be this resistor here. So you could, again, you don't want to measure resistance across a live circuit, so we could touch one of the probes on either end of there, set the multimeter to resistance. That's done with the ohm setting. You might be able to see that over there. So you could measure that, see if that was working. You flip this back over and you can see where this is connected to possibly this component here. And it is. Yeah, it's connected there, so it's connected to that component there. And the component under it is also connected into it. So it looks like all of these connect into this. And then that, I'm not showing that, am I? It's connected into this. And if you again flip it over, that's connected. Let's see. It's right here. And it looks like it's connected in with this, this chip here, which is the, what is that chip? It's the main processor, if I recall correctly. I think that's the video chip. So that's interesting. So you could, again, you can use your multimeter to test the various components. Maybe you have a bad resistor, maybe you have a bad capacitor, figure out if something's wrong there. So let's look at that chip over here. Like I said, that is your, whoops. That right there is your audio chip. You have these 3 chips that are lined up. That 4th chip is the audio chip. And if we look at a pin diagram, we'd find out that the 7th pin is the audio out. So that would be one of those pins on the second to the last pin up there, and we can test that across to see what kind of a voltage reading we might get. And you would do that simply by doing this. That's a good way to do this. There's just not a convenient way to do that. Here's your ground again. Boy, can't seem to. Okay, there you go. Ground, and here's your pin. That's showing offline because right now it's a resistance setting. Let's see if it shows anything No. It's jumping around with some voltage there. And that's with it off. I wonder what happens when we turn it on. As you're messing with this, you want to be aware of the fact that some of these components get kind of hot. So just be careful. I don't think they're hot enough to burn you, but just be aware. So what do we got going on here? 1.93. Yeah, I wonder if I'd have to have, I assume I'd have to have sound again flowing in order for that to show up. Okay, I've got it kind of reconfigured again so that we can run a cartridge. Let it go to a track mode and see if we've got a reading on that audio out pin. Whoops, that's backwards. Okay. That was fast. So it goes to 0 when there's no sound. Isn't that interesting? Whoops. Restarted. Let's play a game. And there you go, a little bit of a tour on what it looks like to try to track down circuit breaks on a computer board. Just a little bit, just a little bit of a taste there. Truly interesting. Learned quite a bit in this. Glad I did it. It's always interesting to reacquaint yourself with computer architectures. So I hope you enjoyed this. I hope you enjoyed the tour here. Keep an eye on the channel, like the video, subscribe to the channel, share it, and keep an eye out because this is life, if I recall correctly.